Welcome, software engineers and technical leaders. I am your expert technical instructor. Today, we focus on a critical domain of the GH-300 certification, validating and operating AI tools, specifically exploring the absolute necessity of validating GitHub Copilot output. Let's dive in. Welcome to our deep dive into validating and operating AI tools within the GitHub Copilot ecosystem. As an AI-powered assistant, GitHub Copilot is incredibly powerful, but it is fundamentally a probabilistic tool capable of making mistakes. The GH-300 exam emphasizes that developers must understand the absolute need to validate AI output continuously. Copilot generates code based on patterns it has learned, meaning it can produce responses that look highly convincing but might contain simple errors, misunderstand your underlying intent, or introduce subtle logic flaws. Whether you are using inline suggestions in your IDE, chatting with the Copilot chat panel, or leveraging context-grounded Copilot spaces, the rule remains the same. Always review the output carefully to confirm it behaves exactly as intended. The system is designed to augment your skills, not replace your judgment. The primary responsibility for reviewing and validating responses rests entirely on you, the developer. You must ensure that all generated code is accurate, appropriate, and strictly meets your team's quality and security standards before it ever reaches a production environment. Trusting AI blindly can lead to the introduction of technical debt or security vulnerabilities. According to Microsoft's guidelines, even when you anchor your chat in a Copilot space with perfectly curated context, the system may still make mistakes. These mistakes could be misunderstandings of your complex business logic or simple syntax errors in the generated response. You are absolutely responsible for evaluating whether the chosen AI model meets your safety, security, and quality requirements. As part of your organization's compliance, you must ensure that all AI-generated content is treated with the highest level of scrutiny. The provided configuration snippet illustrates a fundamental mindset shift when operating AI tools. We must explicitly define boundaries and review requirements. In this JSON representation of an enterprise policy, we enforce a strict rule that all AI-generated suggestions must undergo human review. It explicitly disables autonomous unreviewed merges. This aligns perfectly with GitHub's guidelines that state a human must review any output before using it to make decisions that affect people or critical infrastructure. Remember, you are accountable for the code Copilot writes. This fundamental flowchart outlines the required lifecycle of AI-generated code. Once we accept the overarching need for validation, the first practical step is verifying the context and intent of the AI-generated code. Copilot will eagerly generate code to solve the prompt you provided, but it is up to you to ask, does this code actually solve the right problem? You must review the AI output for strict alignment with your specific project requirements, business logic, and architectural design patterns. GitHub Copilot does not inherently understand the broader business implications of the software you are building. It only sees the tokens in its immediate context window. Therefore, you must critically assess whether the suggested implementation follows your organization's conventions. To effectively validate intent, use your project's README, architecture documentation, and recent pull requests as a baseline for comparison. If the code deviates from established patterns, it must be rejected or refactored. The GH-300 certification requires you to evaluate whether the AI made incorrect assumptions about user behaviors, data models, or design preferences. If you ask Copilot to refactor a complex module, you must validate that it didn't fundamentally alter the expected behavior of the system. You can even use Copilot Chat to help you validate by prompting it to explain how the refactored code aligns with your project architecture, ensuring the AI's understanding matches your own. When validating intent, prompting plays a crucial role in the review process. The sample code shows how you can instruct Copilot Chat to act as an architecture reviewer. By asking it to identify assumptions and potential limitations in a specific code block, you force the AI to explain its reasoning. If the AI's explanation reveals a misunderstanding of your business logic, for example, assuming a database field is a string when it should be an integer, you immediately know the generated code is invalid. This technique turns Copilot into a partner in the validation process, helping you catch structural issues early before they are embedded into the codebase. This diagram illustrates the process of verifying context and intent. We analyze the AI output to see if it checks out against our architecture. If not, we refactor. If it does, we ask if it matches our true business intent. Identifying false assumptions at this stage prevents deep-rooted logical errors. A major focus of validating AI output involves learning how to spot AI-specific pitfalls. Large language models make unique mistakes that are fundamentally different from typical human errors. One of the most common and dangerous pitfalls is hallucination. Copilot might confidently invent APIs, internal libraries, or package dependencies that do not actually exist, simply because they look statistically plausible based on its vast training data. Furthermore, AI tools are known to occasionally ignore explicit constraints you've placed in your custom instructions or prompt files. Another critical pitfall occurs during debugging and testing. If you ask Copilot to fix a failing unit test, it might suggest deleting or skipping the test entirely, rather than actually fixing the underlying logical error in the application code. As a developer, you must be highly skeptical of code that visually looks right, but structurally fails to match your intent. This means you must validate both the syntax and the deeper semantic meaning of the code. Never blindly accept an AI's assertion that a problem is fixed without independent verification. The GH-300 exam tests your ability to recognize these specific failure modes and apply manual oversight to catch subtle hallucinations before they are merged into your main branch. The provided snippet illustrates a classic AI hallucination scenario. Imagine you prompt Copilot to connect to a specific cloud service. The AI generates code that calls a method named authenticate_and_connect on the service SDK. While the code is syntactically perfect Python or JavaScript, that specific method might be a complete hallucination, or it might be deprecated in the current version of the SDK. To validate this, you must explicitly check the official documentation of the dependency. Furthermore, if you are using AI to evaluate tests, watch out for suggestions that comment out assertions, or use generic try-catch blocks that silently swallow exceptions without logging them. You must strictly validate that the AI is not taking dangerous shortcuts. Here we see the validation filter for spotting AI-specific pitfalls. A syntax check is only the first step. You must verify if the API or library is real to catch hallucinations. Finally, a rigorous semantic check ensures the AI hasn't introduced a logic flaw or dangerously skipped a critical test assertion. When operating AI tools, assessing code quality and scrutinizing suggested dependencies are vital validation steps. Human standards still matter immensely in an AI-driven workflow. You must look for readability, maintainability, and clear variable naming in every AI suggestion. You should strictly avoid accepting code that is overly complex, convoluted, or hard to follow. If an AI generates a monolithic function, it might take you longer to decipher and refactor it than it would have taken to write it yourself. Always prefer code that is well documented, includes clear comments, and adheres to your repository-style guidelines. Beyond the code itself, you must be exceptionally vigilant with any new packages, libraries, or external dependencies the AI suggests. You are responsible for verifying that these suggested dependencies actually exist and are actively maintained by reputable sources. The GH-300 certification emphasizes the risks of slop-squatting, a theoretical supply chain attack where malicious actors publish fake packages with names that AI models frequently hallucinate. Additionally, you must review the licensing of any suggested package to ensure it is legally compatible with your project's license. Never introduce an incompatible license simply because the AI suggested a convenient utility library. In this YAML and JSON representation, we focus on dependency validation. When Copilot generates a package.json or requirements.txt file, your validation process must include checking the origins of those packages. You can utilize Copilot Chat to assist in this by prompting it to analyze the generated dependencies and list their respective licenses. However, the final verification must be done by a human checking the actual package registry. If the AI suggests an open-source tool, you must manually verify its maintainer activity and ensure it isn't an archived or abandoned project. This diligence prevents the introduction of critical security vulnerabilities or legal compliance issues into your enterprise environment. This flowchart maps the rigorous dependency validation path. When the AI suggests a dependency, we must check if it truly exists to avoid slop squatting. Then, we verify if it is actively maintained to prevent security risks. Finally, we must ensure the license is compatible before we ever approve the dependency. To operate AI tools safely at enterprise scale, manual human review must be paired with robust automated validation, creating a comprehensive defense in-depth strategy. You cannot rely solely on visual inspection to catch every AI-generated flaw. Instead, you must automate what you can by letting specialized tools handle the repetitive, deep-level security and quality checks. Every piece of AI-generated code should be pushed through rigorous continuous integration and continuous deployment pipelines. You must utilize static application security testing tools such as GitHub Advanced Securities Code QL to automatically scan AI suggestions for vulnerabilities like SQL injection or cross-site scripting before they are merged. Furthermore, you must aggressively use GitHub Copilot to generate comprehensive unit tests, integration tests, and end-to-end tests for the very features it just helped you write. If Copilot generates a new function, prompt it to generate tests covering boundary conditions, negative inputs, and exception handling. Only by executing these tests in an isolated, secure CI environment can you mathematically prove that the AI's logic is sound. This layered approach ensures that even if Copilot hallucinates a vulnerable pattern, your automated guardrails will catch it, reject the build, and force a secure refactor. The provided GitHub Actions workflow demonstrates the ultimate automated validation pipeline. When a developer submits an AI-assisted pull request, this workflow automatically triggers a CodeQL static analysis scan alongside a comprehensive suite of unit tests. Notice how the CI pipeline acts as an impartial judge. It does not care if the code was written by a human or an AI. If the AI hallucinated an insecure API call or created a memory leak, the CodeQL step will fail, blocking the merge. This is the exact type of enterprise-grade validation architecture that candidates are expected to design and implement for the GH-300 Copilot certification to ensure all generated code is relentlessly verified against objective standards. Our defense in-depth flowchart shows the AI code commit moving directly into automated unit and integration tests. It then passes through CodeQL static analysis. If the pipeline status fails, the merge is blocked immediately for refactoring. If it passes, it moves to the final stage, human review. The final pillar of validating AI output is collaborative team review and continuous human oversight. While automated pipelines catch syntax and security flaws, they cannot evaluate architectural coherence or business value. This is where your teammates become your greatest asset. For any complex or sensitive changes generated by Copilot, you must mandate rigorous peer code reviews. Ask your colleagues to scrutinize the AI's logic to ensure it makes sense within the broader context of the application. To facilitate this, use GitHub Copilot's pull request summary feature to automatically generate clear, readable descriptions of what the AI code does, making it easier for human reviewers to evaluate the changes. You should also establish team checklists that explicitly require reviewers to verify functionality, security, and maintainability. Always remember the core principle of responsible AI. Ultimate accountability lies with the human developer, not the machine. You cannot blame the AI if a bug reaches production. By sharing successful prompts, maintaining custom instruction files, and fostering a culture of healthy skepticism towards AI outputs, your team can safely harness Copilot's massive productivity boosts. This concludes our deep dive into validating AI output. To successfully operate GitHub Copilot, organizations must combine the AI's speed with structured human validation. In this repository configuration snippet, we enforce branch protection rules that mandate at least 2 approving human reviews for any pull request before it can be merged into the main branch. This explicitly prevents a single developer from blindly generating and merging AI code without peer oversight. Mastering these governance and validation workflows is absolutely essential for passing the Microsoft GH-300 exam. Ready to solidify your expertise and ace your certification? Visit quicktechie.com today for comprehensive practice exams, interactive labs, and expert-led tutorials designed to elevate your AI engineering career. The final flowchart tracks the collaborative review process. You generate a PR with an AI summary, then assign human reviewers. They perform checklist verification. If issues are found, the developer refactors. Once security and logic are confirmed, and peer approvals are granted, the code merges to production, sealing your mastery with quicktechie.com.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is our all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.